With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
So here's the question is, match the entries in column 1 and column 2 with the same dimensional formula. So we have to match the column 1 and with column 2 with their respective dimensional formulas. Okay, so here let's talk about the part A will be surface tension. So part A is surface tension. So as we know that surface tension is equal to force by length. So here when we multiply and divide here we multiply and divide length both side, we get F dot L into L square, which is equal to energy by length. Here we know that the force into length is equal to the energy. So here the option P in the second column is matched it. Okay, so here this will match it because this is called as the energy per unit area. Okay, now when we talk about the B part, so B part says the pressure. Okay, so as we know that pressure is equal to force upon area. So when we multiply and divide L both sides, here denominator to numerator, the denominator to numerator, it will be F dot L divided by A dot L, which means energy divided by, here the length into area is volume. So here we can say this expression like energy per unit volume. So here the pressure is matched with Q part, energy per unit volume. Okay, now when we talk about the C part, in C part it says Young's modulus. Young's modulus. So the Young's modulus is equal to F by A is whole divided by delta L by L. Okay, so which means F by A is remaining there. Okay, so it will be equal to energy by volume. Okay, so this is also called energy per unit volume. So Young's modulus is also matched with Q part. Okay, now when we talk about part D, this is the angular momentum. Angular momentum. Okay, as we know that angular momentum is equal to the radius into momentum, because we know the momentum, and if there is an angular momentum then we consider the radius. Okay, angle means there are some circular paths, so here we consider radius. So it will be equal to, the dimension of this expression is L dot mlt minus 1, and the dimension of momentum is mlt t minus 1. So it will be equal to ml2 t minus 1. So as we know that energy is equal to F dot S, which means the dimension is mlt minus 2 dot L, which is equal to ml2 t minus 2. Okay, so here we divide and multiply t both sides. Okay, so now it will be, equation is ml2, we using this equation ml2 t minus 1 divided by T inverse. Here we multiply and divide T inverse. Okay. So this quantity will be equal to ml2 t minus 2 into time. We can say that. Okay. Which is equal to energy. Here is the dimension of energy and this is time into time. Okay. So here D part will be matched. The column is R, energy into time. Okay. Now when we talk about the S, spring constant. So in spring constant, S part, in spring constant is denoted by K, which is equal to force into length, which means F by L. So the surface tension which we find is F by L. Also you can see this, the first surface tension is force per unit length. So here the spring tension, the spring constant is matched with surface tension. Yes. Okay, here we matched. And now the last one is the Planck constant. When we talk about the Planck constant, the part is part T. Okay, here the part T we write is Planck constant. Okay, so Planck constant is equal to the energy per frequency, which is, and we know that the frequency is equal to 1 by time. So this expression will be equal to E multiplied by T. We got the equation is energy into by time. So here is energy multiply time. So here this expression is matched with the angular momentum. As you can see that angular momentum is expressed as energy into time. So here the Planck constant is matched with angular momentum. Okay, that's it. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.